Okay, so we have seen Laplace transform of some elementary functions, and then we saw the properties of Laplace transforms. Now we'll see Laplace transform of periodic functions. Up till now we were transforming functions, not periodic functions. So let's see the Laplace transform of periodic functions. What are periodic functions? Let's say we have a function with a period capital T. So we have a function with a period t. Then ft plus t will be ft. This is a periodic function. For example, sine theta plus 2 pi is sine theta. This is a periodic function. Why? Because after 2 pi the function repeats itself. 0 pi 2 pi. So after 2 pi it is same. So this is a periodic function. It keeps on repeating after that particular period. So how do we transform, or how do we do Laplace transformation of periodic function? So let's say our function is ft. Then the Laplace transform of ft is given by 0 to t e to the power minus st ft dt by 1 minus e to the power minus s capital T. This is how we transform a function which is a periodic function we will see an example and then we'll know how to transform it. Our example is, we have a function ft which is equal to v sine omega t for t between 0 and pi by omega, and it is equal to 0 between pi omega and 2 pi by omega. So the time period here is 2 pi by omega, but we won't be having any value of integral between pi by omega to 2 pi by omega. So effectively the integration from 0 to 2 pi by omega will be equal to the integral between 0 and pi by omega. What is the Laplace transform of this function? This will be 0 to t, that is 2 pi. First of all, I am writing the whole function. ft e to the power minus st dt by 1 minus e to the power minus, time period is 2 pi by omega. So this is 2 pi s by omega. So between 0 and pi by omega we will have this function, and then from pi by omega to 2 pi omega we will have 0. So we can write it, what we will get is v by 1 minus e to the power minus 2 pi s by omega 0 to pi by omega e to the power minus st sine omega t dt. This is what we have got. So let's go ahead. This is equal to v by 1 minus e to the power minus twice pi s by omega, and what is the integral of this? You remember, it is e omega t sine bt dt. So we have a standard integral. I'm directly writing the answer. Go and check my earlier videos if you have any confusion. So this will be e to the power minus st by s square, this is a, plus this is b, omega square, and then in bracket minus s sine omega t minus omega cos, cos omega t. This is what we get, and the limits are 0 to pi by omega. So this is equal to v by 1 minus e to the power 2 pi s by omega. First is pi by omega, so this will be e to the power minus pi s by omega by s square plus omega square. What we will get? This is pi by omega, so this will become sine pi. What is it? 0. So this term will be 0 minus omega cos pi. What is cos pi? Minus 1. So this will become omega minus plus. Sine of 0 is 0 plus omega. Oh, no, sorry. This is the first part. Then second part, e to the power 0, that is 1. So 1 by s square plus omega square, and what we got here? This was 0, this is 0, and this is 1, that is omega. So this can be written as v by 1 minus e to the power minus 2 pi s by omega into s square plus omega square is common, and what we have got here, this is e to the power, see, omega is common, so we can take out omega, and then this is 1 plus e to the power minus pi s by omega. But we see a pattern here. See, this is a square minus b square. This is a plus b. So here we'll get a minus b. So this will effectively come to, I'm writing it here. This will be v omega, this cancels. So in the denominator we'll get 1 minus e to the power minus pi s by omega into s square plus omega square. So this is our answer. So this is how we take the Laplace transform of periodic functions.